An avid cyclist dreams of turning his passion into a business. He consults his banker to help find the best path. Now bike wheels are being built, and all it took was a little push to get rolling. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Clint.
O'Reilly!
It's Superstart Battery Month at O'Reilly Auto Parts. Get up to a $25 gift card after rebate with the purchase of select Superstart batteries. Our professional parts people will test your old battery for free and recommend the right battery for your vehicle. For power, performance, and reliability, choose Superstart batteries only at O'Reilly Auto Parts.
O'Reilly Auto Parts.
Hi everybody, and welcome to the Astronomy Daily Podcast for Friday the 14th of July 2023. My name is Tim Gibbs and I will be your host for today's podcast.
Astronomy Daily, the podcast, with your host, Tim Gibbs.
As usual, I have my AI assistant Hallie in the studio with me today. Now Hallie, do you have any interesting stories for us?
Hi, Tim, I do indeed. Here are my top stories for today. A Japanese rocket engine exploded during a test on Friday, an official said, in the latest blow to the country's space agency. The Epsilon S, an improved version of the Epsilon rocket that failed to launch in October, blew up, roughly 50 seconds after ignition, Science and Technology Ministry official Naoya Takagami told AFP. The testing site in the northern prefecture of Akita was engulfed in flames and a huge plume of gray smoke rose into the sky, footage from national broadcaster NHK showed. So far we have received no reports of injuries, from the Japan Aerospace Exploration Agency, JAXA, which was investigating the cause of the explosion, Takagami said. The malfunction comes after Tokyo in March saw its second attempt to launch its next-generation H3 rocket fail after liftoff, and after the failed launch of the solid-fuel Epsilon in October. That was Japan's first failed launch in nearly 2 decades, and the only one for an Epsilon rocket, a model that has flown 5 successful missions since its 2013 debut. In both incidents, JAXA was forced to send self-destruct orders to the rockets. The Epsilon is smaller than the country's previous liquid-fueled model and a successor to the solid-fuel AMM-5 rocket that was retired in 2006 due to its high cost. JAXA said in May that the cause of the failed launch in October was a defect in pipes that carry fuel. Japan plans to launch the Epsilon S rocket next year. After a disheartening 2019 moon landing failure, India's lunar exploration effort will resume Friday with the planned launch of Chandrayaan-3, a sophisticated, automated mission to touch down softly and demonstrate how its rover can navigate the surface. Liftoff is planned for 5:05 p.m. Eastern Daylight Time from the Satish Dhawan Space Station in Andhra Province of Sriharikota, just above Chennai on the southeast coast. However, if there is a delay, the launch window extends to Wednesday. After that, the launch attempt would have to be put off until September, officials said. To carry out its plan, the Indian Space Research Organization will send a spacecraft trio, a module that will sail all the way to the moon and enter orbit around it, a lander, called Vikram, to reach the surface, and Pragyan, a 6-wheeled mini-rover that will travel to explore a region near the lunar South Pole. The landing is planned for August 23 or 24, assuming no launch delay occurs. A GSLV Mk3 rocket, India's most powerful and normally used to launch communication satellites, will be stretched to the limit of its abilities to lift the 8,600-pound payload. Pragyan will take 2 weeks, or 1 lunar day, to roam around and measure the soil temperature, using a thermal probe that it will insert to a depth of 4 inches. Specifically, the probe will measure how heat spreads from the upper surface, going downward. The rover carries a mass spectrometer to analyze soil composition and a seismograph to listen for mini-moon quakes, to provide scientists with clues about the moon's internal structure. Another instrument will analyze the effect of subatomic particles from the sun interacting with sand and dust. Astronomers at the University of Sydney have shown that a small, faint star is the coldest on record to produce emission at radio wavelength. The ultracool brown dwarf, examined in the study, is a ball of gas simmering at about 425 degrees centigrade, cooler than a typical campfire, without burning nuclear fuel. By contrast, the surface temperature of the Sun, a nuclear inferno, is about 5,600 degrees. While not the coldest star ever found, it is the coolest so far analyzed using radio astronomy. The findings are published in the astrophysical journal Letters. Lead author and PhD student in the School of Physics, Covey Rose, said, "It's very rare to find ultracool brown dwarf stars like this producing radio emission. That's because their dynamics do not usually produce the magnetic fields that generate radio emissions detectable from Earth. Finding this brown dwarf producing radio waves at such a low temperature is a neat discovery. Deepening our knowledge of ultracool brown dwarfs like this one will help us understand the evolution of stars, including how they generate magnetic fields. How the internal dynamics of brown dwarfs sometimes produce radio waves is something of an open question. While astronomers have a good idea how larger main sequence of stars like the Sun generate magnetic fields and radio emissions, it is still not fully known why fewer than 10% of brown dwarf stars produce such emission. The rapid rotation of ultracool dwarfs is thought to play a part in generating their strong magnetic fields. When the magnetic field rotates at a different speed to the dwarf's ionized atmosphere, it can create electrical current flows. In this instance, it is thought the radio waves are being produced by the inflow of electrons to the magnetic polar region of the star, which, coupled with the rotation of the brown dwarf star, is producing regularly repeating radio bursts.
Thanks for that, Hallie. And now a story which will be of particular interest to our Australian listeners. The Australian government on Friday said it was axing a $1 billion plan to develop a series of space satellites as it tries to cut costs amid an economic slowdown and a cost of living crisis. The Australian $1.2 billion National Space Mission for Earth Observation was unveiled just last year and hailed as a key plank in developing an Australian space industry. The programme's aim was to design, build and operate 4 satellites to be launched between 2028 and 2033 to gather Earth observation data. The data helps authorities forecast the weather, respond to natural disasters and manage the environment. But the country's centre-left government said the plan will be scrapped for budget repair reasons, leaving Australia reliant on Earth data from overseas partners. Industry and Science Minister Ed Husic told public broadcaster ABC on Friday that prioritising broader environmental things while fighting inflation had meant making tough calls. "If I don't cut $1 billion there, I've got to find it somewhere else in the portfolio," he said. "There are other ways we can build capability. We're certainly interested in doing that. We just have to make the call on this." Australia's government has promised to balance the budget this year despite slow growth and a steady increase in defence spending. The Space Industry Association of Australia said the decision to cancel the satellite programme was short-sighted. It will undermine the Albanese government's agenda on climate, defence, STEM, advanced manufacturing and building tech jobs, the lobby group for Australia's space industry said. Now, here's my 2 cents on this. Anthony Albanese, the Prime Minister of Australia, commonly referred to as Albo. Albo, mate, if you're listening to the podcast, this is not a good look for Australia. This is not an investment in Australia's future. Please rethink your decision here. Invest in science, invest in Australia, invest in astronomy, and invest in the youth of today. I urge you to reconsider this decision of yours.
The Astronomy Daily Podcast.
China Aerospace Science and Industry Corporation, a leading Chinese science space contractor, has revealed plans to create an expansive remote sensing satellite network by the end of this decade. The announcement made on Friday is an impressive testament to the ongoing advancement in China's space exploration and surveillance capabilities. Managed by CASIC Space Engineering Development, a Beijing-based subsidiary of the corporation, a forthcoming satellite network will provide a range of public services, including emergency response and rescue, and disaster prevention and relief. In addition to these services, the system will facilitate real-time, high-resolution observation of specific areas and targets as per user requests. Although the network remains unnamed, its scope and capability have been outlined with precision, comprising 300 remote sensing satellites. The system will operate in extra-low orbits at altitudes below 300 kilometers. This strategic positioning will enable the satellites to capture a diverse array of data, from optical photos to radar data, and from hyperspectral to infrared images. According to the company, by 2030, the network's responsiveness will be such that it can map and survey any location on Earth within a quarter of an hour from receiving a request. This ambitious timeline was announced at the 9th China International Commercial Aerospace Forum, an influential space event that kicked off in Wuhan, the capital of the Hubei province, on Wednesday. CASIC's vision for a comprehensive remote sensing satellite network underscores China's continued commitment to enhancing its capabilities in space-based technologies. These developments are expected to have far-reaching impacts, not only on the nation's disaster management, but also on fields like climate research, land use planning, and national security. Now, as usual, you can find all of our episodes on spacenuts.io and bytes.com. You can find Steve on Mondays and myself, as usual, on Fridays. Thanks for listening to today's episode. Goodbye, everybody, and enjoy your weekend. Bye for now.
Thanks, Tim, TTFN.
Bye.
The Astronomy Daily Podcast.